Welcome to Blueprint to Reality. Today, we're unraveling one of the most fundamental questions in civil engineering. Why do buildings stand? Let's dive into the science of structural stability. The concept of structural stability. At its core, the stability of a building is about balance, balancing the forces acting on it, and ensuring the structure can carry its own weight and any external loads. Buildings stand because they are designed to handle a range of forces, like gravity, wind, and even earthquakes. A stable structure means that all these forces are properly managed and redirected into the foundation, allowing the building to remain upright and functional over time. 1. Gravity and dead load. First and foremost, buildings must support their own weight, also known as the dead load. This includes the weight of walls, floors, roofs, and every other permanent part of the structure. The force of gravity pulls everything toward the earth, so the building must be designed to resist this downward force and ensure that it's evenly distributed. The materials used in construction, steel, concrete, wood, are selected based on their strength to support this dead load. Engineers calculate how much weight these materials can safely hold without buckling or collapsing, ensuring the building's foundation and frame are up to the task. 2. Live load. But buildings don't just have to support their own weight. They also need to handle live loads, which include things that change over time, like people, furniture, and equipment. Engineers account for these dynamic forces, ensuring that the building remains stable even when it's filled with occupants or heavy machinery. In areas like offices, schools, and homes, live loads can vary significantly. The design must be flexible enough to accommodate fluctuations, like a crowded event or heavy snow on the roof, without compromising stability. 3. Wind and lateral forces. Next, we have lateral forces, especially from wind. Wind doesn't just blow against the side of a building, it can push and pull on the structure, causing it to sway. Engineers account for wind loads by designing buildings with lateral support systems like braces, shear walls, or moment frames. These elements help the building resist side-to-side forces and prevent excessive swaying. Tall buildings, in particular, are prone to wind forces. Skyscrapers often use a tapered design or add dampers, which absorb and dissipate wind energy, preventing the building from becoming unstable during strong winds. 4. Seismic forces. In earthquake-prone areas, structural stability is even more critical. Seismic loads introduce horizontal and vertical forces, shaking the building's foundation. Engineers use techniques like base isolation, cross-bracing, and shock absorbers to prevent excessive movement and ensure the building can withstand these intense forces. Buildings in earthquake zones are designed to be flexible enough to absorb seismic energy without collapsing. This flexibility allows them to sway safely instead of rigidly snapping under the pressure of an earthquake. 5. Foundations and load transfer. All the forces acting on a building, gravity, live loads, wind, and seismic forces, must be transferred safely into the ground. This is where the foundation plays a crucial role. Foundations are designed to evenly distribute the load across a large area, preventing the structure from sinking or tilting. Deep foundations, like piles driven into the ground, are used for tall or heavy buildings to reach stable soil layers. Shallow foundations, like slabs or footings, work for smaller structures where the soil can support the load at surface level. Conclusion. So, why do buildings stand? It all comes down to managing forces and ensuring stability. Engineers balance the downward pull of gravity with the push of lateral forces like wind and earthquakes, transferring these loads safely into the foundation. With careful design and material selection, buildings stand tall and strong, even in the face of the elements. Thank you for tuning into Blueprint to Reality. If you enjoyed this deep dive into structural stability, be sure to like, comment, and subscribe for more civil engineering insights. Until next time, keep building the future.